Hello to everyone. On the continuation of my previous presentations, now we are going to see about how or why do we measure error. So the error is expected in all kind of the data collection, even in that process also, or whatever that surveys we are taking. The error may be in the form of either non-sampling error, or it may be in the form of that sampling error. You may ask, so why I have to measure that is the error? So let us know, so how much percentage of the error should be there? That has to be computed from that populations. So that will determine how much of the accuracy our data set it has. So for measuring of the error, now we are going to see some relative tools how we have to measure all these kind of that errors. So now we are going to see about that is basic parameters to measure that is the error. Everyone know the one is called that is the standard error, and another one is called that is relative standard error. So now we have to see what is the meaning of that standard error. So SE is a measure of the variation between any estimated population value that is based on the sample rather than the true value for the population. So the standard error, so that always be happen. In previous example, in previous part of that video, so what I said, in case if I am going to make a survey for that next forthcoming election, I can't able to meet out that entire population of the state. I can't able to meet that people of 8 crores, those who are residing in the Tamil Nadu. That never possible. So what I do, so I have to be clustered, the district wise, and then I have to meet the people as a group wise, and then I have to collect the data, and then I have to inference the collected data with the rest of the population. So that will make and standard errors. But the standard errors always affect the accuracy of the estimates, and also the importance of the interpretations drawn from the data. So sure, the standard error will always make an impact in that accuracy. And next, how we have to be compute that is that standard error. So the standard error, it's having that formula is called SE x of bar equal to S, that's whole divided by square root of the n. So the S is stating about the standard deviation of the population, and the n is the size of that sample. So from that I can able to make one beautiful computation. What's my standard error happened in my data? So the standard deviation of the entire population, you may take about that certain attribute, and then for that attribute you have to compute the standard deviation of the population, and from that standard deviation of the population you have to be find out that square root of that size of that sample. So by this ratio I can able to come to a conclusion what is my standard deviation of my sampling distribution. So the value, it seems to be that appropriate, and there is no issue. So the value seems to be that more, and then the data what we collected, it's having the more standard error. And then so next we are going to be see about relative standard error. So the RSC is the standard error that is expressed as the proportion of an estimated value. That means that relative to the standard error. So that is also one useful measure, and it's having the indication of the relative size of the error likely occurred so due to that sampling. I may collect that is the data, but it's a certain relevant attribute may have the certain variations. So the thing may be happen. I met that people, and then that people may not say their age, and then I can able to come to the justification by their appearance. The people may be in the age group of some 30 or that's a 25, but the people may be in the age group of 18. So such a error is called the relative standard error. So the relative standard error and versus standard error, we have to see the standard error that measures indicates the extent to which the survey, the estimates likely to deviate from true population and to the expressed as a number. The relative standard error, they always expressed with the fraction of that estimate and with the expressed as in a form of that percentage. So the RSC, that always we talking with the percentage, and in the standard error it's always talking about that value. And next kind of one error we are going to be seeing that statistics is called that is the probable error. So this probable error will happen when we have to be taken into that range. In previous example, so in that age, so I collected some 1,000 data of that one ward in the age group of 18 to 25, but in particular ward the 18 to 25 population may have some 10,000 or that 15,000, so I have to make an inference with that remaining data set. So there it maybe creates that is the probable error. So when I have to be go with the symmetric distribution, so there I have to be compute that half of the interquartile range or by that median of the absolute deviation. So when we have to talk about that is the probabilistic error, so the value always should be in between 0 and to 1. That means 0.0 to that 1.0. So it's making that relativity with that standard errors. So the SE should be lies between 0 and 1. So and the probable error of that coefficient of the correlation. So already we know, so what is that correlation? So that has been given in the formula. The correlation of the PE is the standard values of the 0.6745 that should be multiplied by 1 minus r square, that is divided by square of that n. So this R is talking about the coefficient of the correlation, and then n is representing the number of the pairs of that observations so we had. And then, so the measure of the error tell with what? So the confidence interval and then so how the data it's having its true population value is there. So this is that confidence. So when I have to apply that statistics and then the confidence interval when I have to apply that is the normal distribution for my data. So it's having that confidence interval 95% and then it's having very good parameters. So the percentage that has been reduced, it's having that more error. So when we have to go with the normal distribution, we should be concentrate what is my least cutoff value and what is my upper cutoff value. The lower and then so upper cutoff value making the prominent role when we have to be talking about the normal distribution. So the confidence value should be more. And then the error case, so if the value of that R, the correlation of that R is less than PE, the value of that PE, and then the correlation seems to be that insignificant. If the value seems to be that greater than that PE and it's having that good significant, if that value is less than 6 of that PE, the sample size seems to be that too small for that any estimation. So always the correlation value of that R should be more with the 6 times of that PE, so then we can able to come to that conclusion or is having that significant. And we can able to classify the error in 2 types. It's called that is the type 1 and then so type 2 error. So this type 1 error, it's always talking about true null hypothesis. The type 2 error is always talking about false null hypothesis. So that means there is a false negative when we have to talk about the null hypothesis, and then when we are talking about a true null hypothesis, this is talking about that is the false positive. That means false positive and then false negative findings. So this is the situation. So now we have to say about a certain error with the type 1. So now taken an example. So I am a patient, I am taking a test, and then it shows it's having a certain disease. But in fact, the patient not having that certain disease. So this is called as a type 1 error. So in the previous slide, so what I said, it is the false positive. I may have that certain results, it's having the true, but in fact, but it's not happening. So this is called that is the type 1 error, that is the false positive. And the next one, it's called that is the type 2 error. That means I'm going for testing, so I'm having that any misalignment in my body. But the test cannot able to detect so what disease I'm having. But actually I'm having that certain defect, or actually I'm having that certain disease. So this is called that is the type 2 error. So this type 2 error is always talking about that is that false negative. So these are all the 2 types of that errors always be happening when we have to be identify and then so detection of that errors. So up to this, I am concluding this topic. So thank you.